So as promised, we're going to take a couple weeks off of hickory identification and explore some other things that are seasonal and timely, what's going on. I had a text a few weeks ago from Danae asking about sapsuckers. And I have kind of a canned response that I give to clients about sapsuckers. And anytime I notice myself saying the same thing over and over about a particular topic, it's a good time to, in my mind, refresh and make sure I'm not handing off bad or misleading information. So I did a bit of a deeper dive into yellow-bellied sapsuckers and came up with some actually interesting information that I thought I would pass along. So does everyone feel comfortable identifying sapsucker damage on trees? Everyone know what sapsuckers are? So, yeah, it's a species of woodpecker that will drill sap wells or holes into trees, and they're easily distinguishable from other like insects that might be boring into the tree, both by their size, and then also they're oftentimes aligned on a horizontal or sometimes vertical plane. And I have had a number of instances where clients thought their tree was undergoing a massive beetle attack, but as you can see, these are some dramatic examples, but in these trees here, there is a noticeable alignment of those holes, and it's just the bird kind of making its way like a typewriter down the tree. And then interestingly, this is something that puzzled me when I first got here that Craig gave me an explanation for. Every once in a while, as seen in this hickory, you see it a lot in loblolly pine as well. You'll see kind of a rib that extends out from the tree, and my understanding, Craig, correct me if I'm wrong, that is wound wood developing around that one of those sort of sections of sapsucker damage. Why it happens with certain areas and not other areas is a question I've not been able to find an answer to. I think I saw in a forum someone suggested that maybe like a virus or something else gets into a particular set of holes, and then that triggers the response from the tree. It could also be that sapsuckers return frequently to the trees that they have chosen to be feeder trees, and perhaps it's just a section of holes that haven't been used in long enough for the tree to respond to it. But just a guess on my part. All right. So what are sapsuckers actually doing? Pretty interesting birds. They are going after the sap. They actually create these little wells into both the xylem and the phloem, depending on the time of year, to lap up the sap that then flows from the tree. And this is something that was new information to me. Sap is kind of a general term. In the spring, it's referring to what is being transported by the xylem, specifically the sapwood. And so it's a highly dilute, mostly water, substance that's like 2 or 3% sugar, I think, especially in the case of maples where it's really, really heavy, that sap flow. And then in the summer when we have more photosynthesis happening, they're actually tapping into the phloem for the more concentrated sugars found in the sap that's flowing there. And supposedly there is also a noticeable difference in the types of holes they produce for each type of sap. So earlier, it's going to be round holes for the xylem sap and then rectangular for the phloem. And let's see, yeah, there's a really wide array of hosts that these trees will go after. They tend to really like the thin bark trees, so you see it a lot in maples and birch. But again, I see it pretty commonly in the loblolly pines as well. Yeah, I've noticed that as well.
You said round holes when and square holes when?
So if I'm remembering correctly, the round holes will be in the spring when they're going after the sap flowing in the xylem. Okay. And in the summer, they will be more rectangular. And let's see, I think you can see that fairly well in the birch there. Yeah. So insects will get caught in those holes that are attracted to the sap, and so the birds will eat those insects as they get caught, and they're also eating bits of cambium. And interestingly, they are considered a keystone species, so other animals are taking advantage of these sap wells that they're drilling. And it is thought, this hasn't been proven, we haven't been able to isolate like a specific substance, but it is believed that the yellow-bellied sapsuckers have an anticoagulant in their saliva that prevents the tree from like closing off these wounds. So it allows sap to flow for a longer period of time. And a number of other animals, this is pretty interesting, like up north, like red-throated hummingbird or red ruby, some type of hummingbird, it's believed that their migration patterns are timed to sync up with the spring feeding of sapsuckers, because the sugar or this highly dilute substance that's flowing from the xylem is similar to the nectar found in flowers, so they're using it as a secondary food source. So they are kind of piggybacking off of the work that the yellow-bellied sapsuckers are doing. But I found information suggesting that bats, squirrels, porcupines, nuthatches, warblers, and even other species of woodpeckers are also secondary feeders on these sap wells that these birds are producing. And then insects, of course, are also benefiting. So keystone species in the sense that there are a large number of other organisms that are also benefiting from the work these industrious birds are doing. And then they're also federally protected, so you can't go in your front yard and shoot them from your tree. The suggested control method is wrapping the affected area with burlap. And oh yeah, one other interesting bit of information was that the birds do prefer stressed trees because of the different compounds that you'll find in the sap when a tree is stressed. Yeah, different amino acids, proteins. So they do have some preferences there that are interesting to note. And then one of the things that clients will often ask about, especially I see this a lot with our southern sugar maple, is you'll see trees that are essentially like black from on the lower trunk or on individual branches. Have you guys seen this or even had people ask you about it? Especially you'll notice it with the sugar maples. Zach, you're nodding your head, yeah. And so sooty mold is a type of fungus that colonizes the sugar found in sap, and as that sap leaks out, you'll get that black substance that is really just affecting the sap. It's not a health concern for the tree. If there are smaller plants, like within the drip line of the tree, and they're getting a heavy coating of this sooty mold, it's possible that it inhibits photosynthesis somewhat, but typically not something that really needs to be worried about. If it's on a leaf, you can really just rub it off. It's the fungus is just colonizing that sap. And interestingly, there are species of sooty molds that are specifically associated with specific types of trees. So there's Scoria spongiosa, which only grows on the honeydew, which is the name for the sap as it's excreted by sucking insects. So there's a sooty mold that will only grow on beech. So a lot of different types of sooty molds. It's not just one thing. And then the other thing that I was interested to note is I'd always kind of heard that sapsuckers don't really do that much damage to trees. If you think about it though, it is poking holes like through the bark into sensitive parts of the tree. So that is a wound that the tree is gonna have to deal with. But more than that, I found some information out from a school in California. It was UC Santa Clara, or UC Master Gardeners of Santa Clara was where I found this information. So different part of the country. I don't know how relevant this is to us, but there is mortality that is associated with sapsucker damage. And from what I read, it sounds like the trees that are tapped most frequently by the sapsuckers are probably going to be most vulnerable to like girdling that happens if they're sort of completely encircling either a branch or a stem. So girdling above the point of feeding is a possibility. And it seemed to be most prevalent with red maples. So I think it's possible that I've seen the dead tops of red maples that, you know, maybe
And hollies.
and hollies.
Yeah, hollies.
Oh, I think I did. Yeah, read that. Thank you. Yeah, Zach mentioning hollies
we see
there.
the weakened tops of hollies, planted hollies, small, thin-barked trees. And hollies, sometimes you'll see it, I believe, on the
Redtip petunias.
redtip,
Yeah.
yeah. I'll see it on cryptomeria. Sometimes they'll kill the whole top of the cryptomeria and then when the one is dead. They're pretty, there's a lot of species. They're not like a certain genus or family of trees. They'll go after all kinds of stuff. So you see it on sweet gum. But it's the small trees that they seem to do the most damage on for ornamentals.
Yeah, that would make sense.
Osmanthus.
And then, so I think that was most of my information for the sapsuckers. Any questions, observations, things you've noted about? Yeah, David?
Sam, a couple questions that I get asked in the field are, like, imagine like a hickory. You see it on a hickory or a loblolly pine. You have that ring, and it's 15 feet in the air. A client will say, so we'll talk to them a little bit about the sapsuckers, and they'll say, so is the tree heavily or highly likely to fail there? where I see that? Like, is there a structural concern where we see the sapsucker damage? My response was always, you know, from Mafek and some other people, of like, possibly, but it's kind of an unknown. What would you say with your research? Like,
So to reiterate what David just said, he mentioned that clients will ask where we are seeing these ribs, if there is a higher likelihood of mechanical failure as a result of like wounding at that point. And I think that my uncertainty would match yours, like possibly.
yeah.
It would be interesting if you guys get a chance, if you're cutting down a tree that has a lot of this sapsucker damage, especially if you're finding these ribs, do a longitudinal cross section like right through that line of sapsucker feeding and take a picture to see if there's any internal decay. I don't know if you've seen cross sections of trees where there's been injections done, but typically there will be little spots of decay like associated with that wounding. I'd be really curious to see if there is consistently any decay, and I would expect there to at least be some on some trees.
Yeah, I'd like to see that too.
Yeah.
So especially the hickories or the loblollies where they have that big sort of tire-shaped thing around them.
But to go back to some of these earlier photos, like if especially this, I believe this was a slippery elm, this photo to your left, like this thing was covered head to toe in sapsucker damage. And it seemed like it'd probably been that way for a long time. And so I would guess that if this is going to be something that is causing enough mechanical damage to worry about like an elevated risk of failure, it's going to be really hard to make from like a level 2 visual assessment to make like an educated guess as to when that might be likely.
A couple of years ago, Craig and I were working in this similar sweet gun, and we saw, I have the piece I'll bring in, it's my house, but we were able to cut through some of it and it seemed negligible, like from our, you know, naked eye, like the structural inconsistencies were pretty negligible. But that's not to say that there's a larger risk on like some of those old ones. I don't know. I had another question though, but after this compliance, did you have something?
I've got a burning question too.
Oh, go ahead.
Yeah, go ahead. Do we think it's the same sapsucker? It's a migratory bird, we know. Is it the same sapsucker that's coming back to the tree year after year, or is it sapsuckers thinking, this is a good sapsucker tree. I see marks on it. I smell another sapsucker. I'm going to go after this one. What's going on here?
Recognizing my extreme limitations of reading I've done about birds, I would defer to more ornithologically minded individuals to answer that question.
That's a solid response.
Okay, so here, what I have read though about sapsuckers, my guess would be that there is, again, this is not my area of expertise, and but these are really interesting birds socially. They have a fair amount of social behavior that I think even us humans would be admirable or that we would admire. So for example, males tend to do quite a bit of the raising of the young. In fact, if there is a single parent yellow-bellied sapsucker family, my reading suggested that they were better off if it was the male taking care of the young than the female. So a pretty even division of labor in that household. They tend to be fairly, I believe, you know, the male isn't out there starting families with a lot of satellite, you know, lovers.
Setting up franchises.
Yeah, setting up franchises. I would, and then I know that in the case of like red cockaded woodpeckers in the sandhills, there are like families associated with specific cavities. And so I would infer with a high likelihood of being incorrect that it's probably the same birds returning to the area. Yeah, and then to go back to your question as I'm thinking about it, I think because girdling is the mechanism of, I'm assuming there are probably also secondary fungi or other issues that can take advantage of these openings and then, you know, pile on additional stressors to the tree. But my guess is those trees that are really preferred, the thin bark trees, are gonna have a higher chance of suffering mechanical weakening as a result of feeding, so birch, red maple, more so than maybe like a hickory or a loblolly pine. But again, I'm inferring, I haven't read that. Really, really quickly, I wanted to go through some, unless there were other questions.
I know your request for time. The only other one was, if not a sapsucker, what is doing this to my tree? My response has always been pretty certain in this area, it'd be like a 90% chance that it's a sapsucker. What are your thoughts on that?
Yeah, if it's creating these, the series of regular holes that are aligned on a plane,
Yeah.
I don't know of anything else that would do that so consistently.
I know someone tied a cable up there,
Yeah.
like a while ago.
Yeah. Oh, certainly if you're looking at a rib, yeah, that could have been,
I stated the question poorly. If not a yellow-bellied sapsucker,
yeah.
what is there another species in this area?
It's blue-bellied.
Yeah, is there another?
Oh, I
is there
see.
ano- sorry, yeah.
So in the West, I think I read that there are up to, again, I didn't specifically dive into this, but my recollection from my reading was there are 4 species of sapsuckers in the West, but I only found reference to yellow-bellied sapsuckers in North Carolina. There may be more species, I just didn't find information on my quick dive into this. But yeah, one other thing that might cause that kind of like rib is if the tree is sort of grown around, cord or something that has not been moved for a long period of time that was wrapped around the tree. But if you look really closely at these ribs, you can see the old sapsucker holes like at
Typically,
the center.
You're not just gonna find one rib, you'll see other evidence of
Yeah.
that same.
Well, I feel like too, they're usually pretty high off the ground. Like if I see some
Yeah.
sort of reaction way down here, I might think of like old dog.
My early hypothesis, seeing it in the loblollies, was I thought I was seeing like partial fiber buckling from compression forces. I way over engineered that hypothesis. I wanted to really quickly just run through some other interesting things I've been seeing right now. So Zach turned me on to this. I hadn't been aware of Keats rust as it expresses itself in Bradford pear recently. But as you're working on a Bradford pear, look for these crazy little orange horns growing off of the fruit in particular. That is a rust fungus. It's a parasite that will that requires 2 different types of hosts. So it'll jump back and forth between juniper and then a pretty wide array of hosts from the rose family. But this is how it looks on Bradford pear. It can girdle small twigs, but my understanding is it won't kill a Bradford pear. I just saw this yesterday. This is something that came up last year as well. Someone had brought this up, and that was my first experience of it. But bird's nest fungus is really, really cool. Look for it in mulch beds. Called bird's nest fungus because the outermost rim looks like a nest, and then they're little hard cases that contain spores in the center, and they're also called splash cups because the distribution method is the cups will grow at an angle, rain hits it at the right velocity, and it shoots one of those little pebbles out, and then over time that pebble sort of melts away, revealing the spores inside. And then also if an insect happens to eat it because it's resting on a plant, it will digest the case and then kind of poop out the spores. So sort of an interesting, and it's a saprophyte or saprophytic, so it is decaying organic material. So from a standpoint of mycorrhizal fungi, we're starting to see some interesting ones pop up. I've been seeing a lot of milk caps. You'll notice they have zonate rings, so kind of like a hypnotoad type pattern in the top of the cap. They are mycorrhizal, frequently associating with oaks in the Rusula family. And then amanitas are popping up right now as well, especially in natural areas. They'll oftentimes have a little skirt below the cap. And right now we're seeing a lot of section lepidella, which includes destroying angel, the mushroom most associated with like death from ingestion in North America. So there is one species of edible amanita, but do not eat them. And then in general, you always, even if you think you have found an edible mushroom and you are determined to eat it, do not eat it raw. All edible mushrooms, except for one that I know of, require cooking. But just don't eat them without, like verifying with someone else. But don't eat them on site raw, especially. And then amanitas are also mycorrhizal. They have a broad host association. There's a lot we don't know about mycorrhizal fungi, but these 2 are consistently mycorrhizal. So kind of interesting to note. Seeing a lot of galls from mites. 3 in particular that are in the same genus, Aceria, that have specific host preferences. On your left, that is black Tupelo gall mite. And then in the middle is finger gall on elm. And then on the right was an observation that Michael B. actually made. And this is Erinium mite that only occurs on beech. All of these have very specific host preferences because each tree will have kind of a different array of allelochemicals or defense compounds by which they try to discourage insect feeding or herbivory. And so these insects require specific suite of enzymes in order to metabolize these compounds without being harmed. So there tends to be a specialization in a lot of these like sucking insects for what hosts they'll go after. And some of them look really cool, but that's all I've got for today.
Nice. Yeah, thank you so much.